My name is Josh. I work on the Spring team. I'm so happy to be before you all today. We're going to talk about the latest and greatest in Spring Boot, my friends. This release came out, the first release of Spring Boot 1.0 came out on 1 April 2014, April Fool's Day in 2014. I'll never forget this release, arguably the most revolutionary release since 1.0, came out 24 November 2022, so Thanksgiving Day, right? Yeah, anyway, that was such an important day that, you know, there's Spring Boot 3 and then there's Turkey. I forgot to do a podcast episode that week because that was normally the day I release it, and I've never forgotten. That was the one time because it was such a big thing and there's so much to do related to that release. Anyway, Spring Boot 3 is a huge, huge thing. Huge. Many years in the making, you might even say, right? By the way, all my coordinates are there. If you have questions, comments, feedback, whatever, I'm online. I've got a new YouTube channel. Come on, people. Join me on the internet. It's going to be great. Coffee and Software. There's the YouTube channel. It's just at Coffee Software. You know, youtube.com at Coffee Software. It won't be the worst thing. It won't be the worst mistake you make today. You know, if you subscribe, it'll be fine. Coffee Software. You know, I've got a book. I'm on Twitter. I'm on Mastodon because the Bird website's like on fire at the moment, and you know, I'm there, right? I'm out there. I'm achingly online, right? And I'm very happy to be talking about Spring Boot 3, which, as I say, is a brand new release, big release, huge release that is a culmination of a number of different threads that all had to sort of wind down in time for this release. And the fact that it did over the scope of years, multiple years, like different threads had to be sort of wound down for this to work, it just blows my mind. It really, really, really is incredible. So we're going to talk about all that stuff today. I do want to start with, you know, some of the bad news. Some things are going to require more than just an upgrade in your version number. Some things are going to require changes in code. Some things don't even work anymore, right? That's to be expected in all things in life, I suppose, but none makes me sadder than this. So let's suppose you go to start.spring.io and you build a new application using the old flavor, right, Spring Boot 2.77, and you hit generate. And let's suppose that you open that here, demo.zip, and you want to change the ASCII artwork. Well, did you know, friends, that if you take an animated GIF, like this one right here, and place it in the source main resources, so banner.gif, demo, source main resources, and then go to that application and you do Gradle boot run, or maybe Spring Boot :run, you'll get an application that converts the image into line art, into ASCII artwork. And I think you can agree they did a great job. Now, this feature is arguably the most important thing that's happened to the Java ecosystem ever. And so it pains me to say that this has been removed in Spring Boot 3. Lame, I know, bothers me. Anyway, yeah, you'll hear no end and no apologies from me on that. I think that's terrible. Terrible. Now, don't get me wrong. They were like, well, what about serverless, Josh? I'm like, so what? Make the serverless wait. It's okay. This can play out each time the function gets invoked. That's fine. That seems like a reasonable compromise. Art has its own merit, but whatever. Okay, so anyway, there's that. That's one bad bit of news. Okay, but otherwise, there's some other changes, and we'll talk about those in a second. But basically, the path forward is pretty rosy indeed. So let's build a new application. We'll go to start.spring.io as always. We're going to build a new application here using the new default build type, which is Gradle, right? You can use Gradle or Maven or Gradle with Kotlin. By default, it's Gradle and Groovy. We're going to build a new service. We're going to call this service, right? I'm very good with names. People always say that. They're just great with names. I am like my dad, and my dad is kind of like the rest of the Spring team, right? If you want to do batch processing in the Spring ecosystem, what module do you use? Spring Batch. What if you want to do data access in the Spring ecosystem? Spring Data. What if you want to do security in the Spring ecosystem? What do you use? Spring Security, right? It's sort of like my dad. My dad, when I was a child, he found a little white poodle in the streets, and so it had no owner. So we took him in, and he became our dog. And my dad, ever so brilliant with names, named it White Dog. And then that dog, I swear, this is not true. This is all true. I'm not like making this up. That dog disappeared like 10 years later, right? Went to a farm upstate. I don't know, right? Another little white dog magically came knocking at our door, right? So what do you think he named that dog? White Dog V2. Just two. And it was either TWO or TOO. Either way, it worked, right? So yeah, anyway, we're going to name this service because guess what? It's a service, and I am great with names. So we're going to build a new application. Friends, we have some choices we always have to make, things that we should think about before we begin our journey building a new application, not least of which is the version of Java that we'd like to use today. Friends, there are 4 radio boxes here, but only 2 valid choices. I know it's confusing. You see, to use Spring Boot 3, you have to use Java 17. Java 17 is the new mandatory required baseline. I don't even know why they show Java's 11 and 8. Perhaps as a reminder of what failure looks like, I think. I'm not sure, though. They have those as just sort of ghosts of what could have been had you made the wrong choice in life. Don't choose those. Don't ever choose those. Even when you can choose those, don't. There's no reason. Java 8 is terrible. Java 17, on the other hand, at a minimum, is quite nice. Java 17 is the right thing to do in 2023. Now, Java 17, remember, is technically superior in every way to Java 8. It's faster, more secure, more performant, more robust, more syntax-rich, more container-ready, more secure. It's technically superior in every way to Java 8. It's also morally superior. You won't like the look of sadness and chagrin in your children's eyes when they find out that you're using Java 8 in production. Don't do it. Be the change you want to see in the world, friends. Do the right thing. So, Java 17 or later, okay? Java 17 is fine. I'm going to use that. Then we have the choice of what versions and what dependencies we want. We want Graalvm native image support just in case we happen to go that way, Glenn. We're going to use Actuator. We're going to use the web support. We're going to use H2, which is an in-memory embedded SQL database. We'll use Lombok because, I don't care about my code. And we're going to use the JDBC support, okay? Very good. So here are all my dependencies. Let's go ahead and generate a new project. Open this up in our IDE, and it doesn't really all that much matter what IDE. Let me see here. Close that all out. Hit generate UAO service.zip. Very nice. Hey, great. Why would you tell me this? Why would you let me install it and then show me that horrible thing? It's not supported anywhere people want it. It's an interesting modal there. Okay, very good. So, public static void main, brand new application. We're just going to build an application that talks to a database. I'm going to create an entity that models that data. Look, right? Very nice. I don't need anything beyond Java records. These are a huge reason for the upgrade. Okay, we're going to create a customer service, and this service is just going to return a collection of all the customer data. Okay, so we're going to create an endpoint here called all. We'll create another one here called by name. Okay, so by name, string name. And in order to do our work, we're going to talk to a JDBC data source. I'll use ye old JDBC template. We're going to inject that here using, Lombok. Okay, fine. And we'll use @service. All right, so I've got just a regular Java object, and I'm going to write some queries here. I'll say template.query, select all from customer. And I need a row mapper to map the records of data coming back from the database into customer records, okay? Voila. So here's this new customer, rs.getID, okay, and rs.getString name. Very good. And turn that into that, and we'll say return this dot customer row mapper. Voila. Okay. What about this one? Return this dot template dot query select all from customer where name equals this, and this dot customer row mapper, and we'll pass in the name. So basically the same trick. In order for this to work, we do need a database. So I'll go to source main resources, and we'll create a new file here called schema.sql. Going to create table customer, ID serial primary key, name varchar 255, not null. Very good. And we need some data, so we'll go back up here and we'll create a new file called data.sql. And here I'm just going to insert some names into the customer table, just some names to represent some typical values that we can find in our database. My name is Josh, of course, nice to meet you. We've got the one, the only, the amazing, the inimitable Jurgen. We've got the amazing Glenn. We've got Pratik and Vincent and who else? Yushin and Madura and Olga and Violetta and Dr. Sire. There's 10 records, okay, friends? That's 10 records. And so now we've got a basic service. We've got an application that will write data to the database when it starts up via that SQL file that we just created. Let's listen for an event here, and we're just going to, when the application starts up, we're going to listen for the event, and we're going to define a dependency on type customer service. So we'll say customer service.all.forEach, and we're just going to print out the results as they arrive, okay, just to confirm that things are working as we expect they will. So let's just go ahead and restart that. I'll take some water. And there's our result. So it's worked. Great. Goody. Of course it worked. That was a demo. It was always going to work. No, friends, that's not really what we care about. What we want to do is to create an endpoint, because once you have an endpoint, people can work with it. And when you have people, you get problems, right? So that's where we want to start, is how do we make our code a little bit more robust? Let's create an endpoint here. At response body, customer, HTTP controller, private final, customer service, voila. And I'm just gonna inject that using Lombok, and we're gonna create an endpoint here called get mapping, by which we'll return all of the customers, right? Like that, just delegating basically to the service. This.customerservice.all. And we're gonna create another endpoint here just by name, okay? So just customers, name, we'll say by name, path variable string name, and we're gonna say by name, voila, okay, very good. So there's our new endpoint. Let's go ahead and restart that and go to localhost customers, and there we are. It's worked very good. Now, first thing, I want to make this application just that much more robust. I want to make sure that if I do a query, for example, for a person by their name, that I get the right result, and therefore I'm going to have to insist on some validation, just some trivial validation. Let's suppose, for example, that we have some rule here that says that the name can't be null and string. We can actually get rid of that first test there. We can just say has a text, right, like that, and name.char@0 is equal to a capital letter, right? So character is uppercase, right? Very good, okay? So if it's good, great, okay? So we're going to say if it's not good, we're going to throw an exception. So throw new legal argument exception, right? The name must start with a capital letter, okay? I'm going to pass in the exception there. Actually, that is the exception. Very good. So there's that. Now, what I want to do is I'm going to have an error. If I were to run this, the framework will intercept that exception, and it'll bubble up to the top, and the client can, will see that. So let's go to the command line here. Curl, that's fine. Lowercase Josh, I get that exception. JQ, there's the response. It's fine. It's certainly what, if you've ever used a Spring API before, this is the default JSON exception representation. It's fine, right? And you even get like you get a -v here. So if I do -v, I get the status code. You can see the status code itself has been updated to reflect the fact that the system is in error. Not a big deal, but it's not particularly consistent. What I want is a consistent way to represent my errors through my services across all my systems. And so about 7 years ago, they created a spec, okay? RFC 7807. Now, this is a way to describe errors in a consistent fashion across different APIs, and it was created in March of 2016. You remember March 2016, right? That was a fun time. Things were better then. So we have a very simple API, but not a big deal. This is certainly not going to be the one and only convenient reason to upgrade to Spring Boot, but it's kind of interesting. So we want to take advantage of that problem details, right? So we're going to say problem details enabled equals true, and then we're going to create a problem details. We could actually create a problem details here in the controller, but as with all Spring code bases, if you have more than one method, you want to centralize error handling, right? You want a separation of concerns. You want your business logic in one place and the error handling for that. If you can't do anything, if there's nothing to be done but to package it up and relay it to the consumer, that should be somewhere else. And so the natural sort of instinct there for Spring developers to build a controller advice. So class error handling controller advice. I'm going to create an exception handler, public void handle. And what is the exception we got? We had an illegal argument exception, gazunt. Okay, so there's our handle. Now I'm going to return a problem details here. So this controller device is a component that Spring will enlist in handling any illegal argument exception thrown anywhere in the web tier. So I'm going to take that exception and I'm going to create my own problem detail. Say problem detail for status HTTP status code value 505. Okay, and of course with that PD I can like set the title, or whatever. I can set the details. I can set the instance. I can add arbitrary properties. I can do all sorts of stuff. But for now we'll just return it like this. So let's go ahead and restart. Let's try that again. So this is the old version. And here's the new one. You got this instance, you got the status code. So it says timestamp, status, error, and path, type, title, status, and instance, okay? Only slightly different, but it is different. And the point is this is consistent. So no matter what API style or framework you're using, now you have a consistent way to represent that. Fair enough. Now, we have an error. We have the ability to return data. I need to measure this, right? If I'm gearing my code for production, and I always am, that's what I care about is production. If I'm thinking about production, then I need to think about measuring and understanding what my system is doing. To that end, we have the Spring Boot actuator. Now the Spring Boot actuator is a set of dependencies, of endpoints that surfaces information about your application, the health, metrics, environment, config props, all that stuff. Now, thankfully, mercifully, those endpoints are locked down by default. You can't use them, you can't see almost any of it. For our demo, I'm going to do a terrible thing that you shouldn't do ever, not even when you're all by yourself at home and no one is looking. I am going to expose all my endpoints. Now, here we go. So we're going to say show, show details. Always, we're going to enable the Kubernetes probes. We're going to show the, we want to say exposure, include, all that. Okay, very good. So we've got just a number of endpoints that'll let us see what's happening as a demo, okay? Here we go, restart. Localhost 8080/actuator/metrics. There we are, there's our endpoints. Very convenient. You've got all this metrics information. You've got env, which gives you environment variables. You've got config props, which gives you the configuration properties to which your Spring Boot application will respond. You've got health, which shows you the different subsystems in the application that, were they to fail, would imperil the service proper. So for things like your database and your file system, that if they died, you'd want to know about it, and that information would bubble up here. We've also got Kubernetes-specific liveness and readiness probes. So if you're on Kubernetes, Kubernetes as a controller orchestrator, as a container orchestrator, wants to know two things. Is your service ready to be put into production? That's the readiness probe. And secondly, is your service able to stay in production? That's the liveness probe. And they basically just, it's true or false, 500, 200, false, true, respectively. And so all that you get for free. Now let's talk about those metrics, friends. These metrics give me statistics. They give me information about the state of the application. So how much disk space I've got, how much time it took for the application to start up, the database connection queue size, whatever. All this kind of stuff you get surfaced here. Just statistics, right? Averages, means, medians, that kind of thing. Oh yeah. Right on. All that stuff is surfaced right here, right? Very convenient, not all that new. You might know that that module is in turn powered by Micrometer. Micrometer is a vendor-neutral application metrics facade that plugs into any number of different time series databases, including Datadog and Graphite and Grafana and Prometheus and whatever. That's fairly old hat, right? Micrometer has been around since Spring Framework 5.0, right? Spring Framework 5.0 came out in 2017 in September. So we introduced the GA version of Micrometer to support the actuator module. You can use Micrometer without Spring Boot and without Spring, right? But Spring depends on Micrometer. This means that everything that uses Spring can also use Micrometer, so it's very convenient. It also means that everything that uses Micrometer doesn't necessarily need to use Spring. So for example, the RabbitMQ library and different drivers for different databases and all sorts of other technologies ship Micrometer integration, right? They use the core SPI, and then you can plug in an implementation, and you can have metrics in a consistent way being shipped out of these different pieces of infrastructure code. Very cool. Now, what happens? Let's say I'm looking at my metrics and I can see the 99th percentile and something is wrong, right? My services are not responding to plan, things are going poorly. I need to drill down and look at the details. Well, now we get into the other side of observability. We look at another dimension of observability, right? We have Micrometer here. We've got Spring Framework on top of that depends on it. You've got Spring Boot on top of that, that depends on it. You've got Spring Cloud, which depends on that. And then the other side of the equation, tracing, has historically been supported by something called Spring Cloud Sleuth. Now, Spring Cloud Sleuth is distributed tracing. It's based on the ideas of, what is it? What is that, a Google, no, 10 years before that. Oh, they did, it's ironic, I forgot. They did a white paper more than a decade ago. And did you know, by the way, the name will come back to me as soon as I get off stage and we've all gone home. Did you know they actually published this paper just because they wanted to be able to reference it in another white paper, and they thought that white paper was going to go viral? So they just published this thing on this white paper establishing how they do distributed tracing, just as we need to have something so that we can cite it, right? That's it. And it turned out that was the thing for which they're, one of the things for which they're well known. Anyway, that mechanism has been there for a while, and it's a generic abstraction, but it is a little bit lopsided, right? Micrometer is at the very bottom of the abstraction stack. It's very bottom of the dependency tree. Anything that uses Spring can use micrometer. Anything that uses Spring Cloud can use micrometer, but not the other way around. Nothing except for Spring Cloud Sleuth can use Spring Cloud Sleuth. You know what I'm saying? The Spring can't reach up and depend on Spring Cloud Sleuth. That would create a circular dependency. So, in Spring Boot 3.0, we fixed that, right? So Spring Cloud Sleuth is gone. It's still there, of course, but I wouldn't recommend it for new code. And instead, we made it so that Micrometer can now do both metrics and distributed tracing. Two sides of the same sort of goal, of the same coin, okay? So now we go back to this. Take that, plus we added new support for a new API called an observation. So you have a unified API to capture both metrics and trace information. So let's go here. Let's say I want to observe this by name endpoint, okay? So I say observation dot create not started, and I'll say ATLJUG, whatever. And then I need to give it a pointer to the observation registry. So I'll inject that here, private observation registry. Whoop, whoop. Very good. Go down there. This dot registry, and I'm going to then observe something. And you can see here, I can just emit value if I want. But what I want to do is I want to create an observation around something. So in here, in this case, it makes sense to observe whatever happens within the scope of that supplier or that runnable, okay? So here I want to return a value. The value that I want to return, of course, is the collection of customers. And then in that supplier, I'll just, do what I did down here. I'll say like that, like that, like that, okay? So now I can just return that as the method. Turn that into a lambda, otherwise I wouldn't be able to sleep at night. Very good, okay? So now we've just observed something. In this case, I'm just talking to my local SQL database, not really much of anything there that I can trace, but suppose instead that service had called to another networked microservice. This would start up a span and propagate the headers to that service, assuming that the call to that other network service used either the REST template or your reactive web client or something like that, right? That would be very, very convenient. Okay, let's go ahead and restart this and see what that looks like. Localhost 80, actuator metrics, refresh. Go to localhost customers, Josh, refresh, 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 refresh. Go back here, refresh some more, and you can see it says ATLJUG. Okay, so go to metrics, ATLJUG, and you get the count of how many times I requested. It was 17. You get the total time that it took to do all that, the max time, etc. And you get the different dimensions. Now, of course, you can plug in your different metrics time series databases here, and that'll do the right thing. Good. Now, friends, this new observation API is really powerful, and we're already retooling as much as we can to make sure that it works with this new API. We've got Micrometer. All those modules now also work correctly in the new Micrometer world. It's a really, really powerful opportunity here to make sure that you integrate both tracing and time series databases. Some tools, like shameless plug, VMware's own Wavefront, support both tracing and metrics in the same database, in the same service, right? VMware Wavefront powers Reddit, for example. Reddit is a small website that I have a feeling one day will get big. People are going to like it. It's going to blow up. You just watch. It's going to be big. But yeah, they're using that. They're using Wavefront. And so that's very convenient. You can actually do pivot tables and that kind of stuff. You can actually say, okay, I see a percentage of people are having issues. Let me drill into the details and see what's happening. Yes, sir. You in the front. Hi.
So those data, are they stored in memory or persisted somewhere?
Like I said, you can use one of the integrations. There's different integrations with different databases, different time series databases. It'll automatically publish the metrics and the trace information to the implementations of your choice. So you can use Prometheus, you can use Wavefront, you can use a number of different implementations.
And does those data has TTL where they're going to automatically expire, or you have to manage the lifestyle?
You mean in the database?
Yes, like the purging, the rotation.
It's up to each implementation, right? Like you really have to see what it looks like when it talks to your thing. There's no particular support here from the client side, though. Yes, sir.
This micrometer stuff you explained, it's already there. Micrometer, you can give a name and say, I'm a coder, or I'm a charge, whatever.
Right, but you didn't have the ability to start and then propagate trace information. That's what the new observation API is doing. It gives me that ability to create an observation where I do .observe, and then in the scope of this, had this been making a network call, I could ask it to propagate trace information to something like, to OpenZipkin or something like that, or Google Cloud Stack Driver Trace. Does that make sense? If this was a network service and it was using a reactive web client or using a regular REST template, and those were instrumented by Micrometer to have tracing interceptors, then automatically trace information would be sent for you just by using it in the context of observe. A little bit of column A, a little bit of column B. Micrometer provides the APIs. Spring is doing it for you. Okay, I can't see. Is there more questions? Are there? Okay, hi.
Can you replace Micrometer with OpenTelemetry, because OpenTelemetry also has both metrics and...
So we have a module that uses Micrometer. It's Micrometer OTel. So you can use that with Micrometer. You in the front. You have something? You look like you're about to inject something. Yeah.
I'm nodding. I mean,
Yeah. Oh, yeah.
But OTel always does it support metrics but not tracing?
I think it does both. I don't know. I thought it did both, but either way, yeah. You can. There is a module that you can use, a Micrometer integration for OTel, right? It's Spring. It's a Micrometer OTel, isn't it? Yeah. Let me see. Let's just Google it. Micrometer. There you go. On the OpenTelemetry website, package provides an instrumentation library for Micrometer. So yeah, it's supported and people use it, and it's new, obviously, because OpenTelemetry is super new as well. So it's not very, there's not a huge ecosystem yet, but give it some time. Yeah. Right. My understanding. Okay, good stuff. Now, let's talk about one of those other things I was telling you about where you might have a little bit of change, a little bit of something might have to change in your application. So I've got the status on that. Let's go back to that problem detail. I got the status. I also want to have the detail so I can get the exception here. And whoops, I can say set detail IAE.getException. You know what else I might want to do? I might want to look at the HTTP servlet request that was involved in making this request that failed. So I can just ask Spring, anywhere in Spring MEC, to inject the current servlet request, right? I can look at that, and I can do all sorts of things here. I can say request.get, let's say headers, for example. I could get the headers. I could do all sorts of things, and you can imagine inspecting that HTTP servlet request and then using that to enrich the details that get sent back by the problem details. That's fine. The only reason I'm really showing it to you is because I want you to be very clear about something. Did you see this? See what happened there? Yeah. You see, it's a subtle change, but it's going to break a lot of code. So much code. A long time ago, in a galaxy far, far away, I don't know, 5 years ago, something like that, 6 years ago, Oracle just ghosted the Java EE community, right? They did, I don't know, it was very passive-aggressive. They just stopped responding to emails, right, overnight. Like there was Java EE, and the Java EE stuff was predicated on participation in the JCP, and the JCP, I guess, in order for them to move forward with any of the specs in the umbrella spec, any one particular spec needed to get approval from the umbrella spec lead, and since Oracle controlled both the a lot of the specs underneath the umbrella and the umbrella spec itself, nothing could get done. You can't release a new version of Java EE if Oracle isn't involved in it, in doing at least the very minimum of saying, yes, I approve, right? And this happened for like 8 months. And eventually, maybe it's more, maybe it's less, I don't remember. It was all, the pandemic dilated everything, I don't know. It was a long time where they just didn't respond. I heard conversations with people that were just, apparently they were just told overnight, you're gonna be doing this now, no more, right? And so, eventually, the community and the outrage, they shamed them back to the table just long enough to agree to open source Java EE. And they did. And nothing is ever simple, right? So they open sourced it, but they did it in such a way that, basically any change to any type in Java EE, be it a change to a method or a new method or a new type or deletion, or even if you fix a spelling mistake, I think that one too, pretty sure any change meant that it had to be in a new package, right? You couldn't change the old javax dot whatever. As soon as you did that, you're in violation of their, because remember, they're very sensitive about namespace interfaces and types being copyrightable, right? So anyway, what this meant was that the lawyers had triumphed where technology wouldn't, right? And it meant that all changes to Jakarta EE needed to be done in a new namespace. And so from a technical perspective, the people that that had to manage this process did as good a job as anybody could ask them to do. The Eclipse Foundation took the Java EE types, and what did they do? They released 8. They released Jakarta EE 8, which is exactly the same code as Java EE 7, but just under the Eclipse Foundation as open source. No changes at all, right? Just the new license and the new docs. People had to rewrite the docs. Oracle didn't donate that, so all the certification kits and the documentation, I think that all had to be recreated from scratch, from whole cloth in like a clean room kind of way. And then they released Jakarta EE 9, which is exactly the same as 8, no changes except they moved everything to the new package, right? Right. So that's, again, they're doing such a good job to make it so that there's an easy migration path. You can just find and replace, and nothing will break, right? Because sometimes things break. And now, finally, with all that behind us, I think, what is that now? Are we in 10? I think they did 10, and that has some much needed, like it's been more than half a decade since these features were needed to be done, and they finally got them in, small ones, and they're already looking forward to the new stuff on 11, I think. So it's been a long journey. My point is, the last time we had Java EE was Java EE 7. We're on Jakarta EE, I think it's 11, pretty sure, right? We're incredibly painful process, but the people that handled it at Eclipse Foundation did a great job. And what it means is that from our perspective, from consumers of these APIs, and from your perspective as consumers of these APIs, hopefully, fingers crossed, you're going to have to just do a very, very, very aggressive find and replace on your code base. We already did that process. The Spring team proper, we did that process for the last several years. We've been working with all these different integrations, all these different libraries across the ecosystem to pull in the new dependencies, right? And to wait for them. So at one point when we started the development on Spring Boot 3, we had a branch where we just commented out like a bunch of modules because they all were red. They're all broken, right? Because they're now bringing in the new Jakarta EE types. But not all libraries supported these types yet. They're all supported javax. So we waited for, like, oh, are you using Jakarta yet? Great, we'll add you back in. Are you using it yet? Great, we'll add you back in. And it's just been a nightmare, right? Just an insane process. So anyway, that works, but you wouldn't believe the craziness involved in making that work. Okay? And I would expect your IDE will probably have some support, if it doesn't already, for moving to these new types. Glenn, is there something they can use to move besides just grep, egrep? Is there something they can use to easily move to those new types yet? Is that a thing yet? Is that public? I don't know. Is it real? I don't even know. But there's got to be something out there people can use. I don't know. I don't even know if that's like, I don't know. No, not that. Is there like a plugin or something? I mean, besides the find dialog? Whatever, you can just use find in project. That'll work. That should be the extent of it right now, right? I would be very surprised if you don't start to see more sophisticated approaches to like just make that as easy as possible, right? With lots of options out there, right? All the different tools, all the different vendors know, about this requirement, and they're working on it. Okay.
If I understand that package of Java
But not for everything. Only for the, like your old XML libraries are still under there, I guess. All the whatever used to be Java, which if you think about it, could just be Javax EE, but no, whatever used to be under Java EE is now called Jakarta EE. Those things are now Java Jakarta dot whatever. Yes, basically yes, but not quite. There's always an asterisk. It depends, right? Yeah. Any other questions on that one? Besides why? Excuse me. Besides why? Okay, moving on. So we have our application. We've moved it to the latest and greatest. It's observable. We looked at error handling. I think we're ready to start thinking about production, which again is the reason we're here. I care about getting us to production. So I want to take this application to production. The first step, obviously, is to build a container, right? I need to build a Docker image. Obviously, this is old hat. You can use the Spring support for build packs, right? So build packs are this is not new. This is not even close to new. But it's a Cloud Native Computing Foundation specification. There's a CLI called pack. You give it a code, you give it a repository or an artifact, be it a .jar or .war, a Ruby on Rails app, or a Python application, or a Node.js application, or a Ruby application, or .NET EXE, or a I can't say it, it's not a language, I refuse. Anyway, you can use whatever you want and easily pass it into the CLI, and it'll give you a Docker container that you can then Docker tag and Docker push and use in your container orchestrator of choice, which is Kubernetes, right? It's fine. That works great. And by the way, those are great, by the way. Build packs are great. It's open source, so all the recipes, all the things that we use to transform a particular artifact into a container, those are basically open recipes. The nice thing about that is that they're centralized. So anybody can override those. Anybody can work on those, right? You can actually use our default built-in support for these things if you want. And if you don't want, if you want to do something that for some reason we haven't thought about and the community hasn't thought about, then that's fine. You can just you can fork it and add something to that build pack, and that way you get consistency, in your deployments. If something goes wrong, you just change the build pack and then re-image your containers, and you're done. Easy. The whole organization benefits from that. So build packs are great. You can use the pack CLI, right? But Spring Boot actually has support, so you can use Gradle. Not this one. Service. Gradle tasks. Okay. Let's see. I forget the name of the image. Build image. Build an OCI image of the application using the output of the boot jar task. So that's one way. And of course in Maven it's Maven spring-boot : build -image, right? Yeah, that sounds more right. So either way, you get an OCI container. I'm not going to show you that. I just want to remind you that's there. But what I want to talk to you about is I want to get this application to production, and I want it to be as efficient as possible. Now, it's important to remember that Java is super efficient, right? We already talked about some of the things that you can do. We talked about checkpoint and restore, crack, right? That's an amazing piece of technology, right? It's phenomenal. It's actually faster than GraalVM in some cases, right? You can get some amazing numbers out of that. And the fact that that's possible with Java, it just shows what an amazing ecosystem we live in. There was an interesting study that came out 4 or 5 years ago that looked at normalized global results for energy, time, and memory across different languages. And if the baseline is C, and slightly better is Rust, and C++ slightly better, slightly worse, and then Ada slightly worse still, Java is slightly worse still at 1.98. So almost 2 times as inefficient as C, or 2 times less efficient than C, okay? And just for reference, and I love Python, so this hurts me, but here's Python. The only concession is at least Ruby, sorry, not Ruby, Perl. Ruby is son of Perl. So anyway, 75. That means it's 35 times worse than C. So anyway, Java is very good, really good, phenomenal numbers, especially considering that among the other languages in this list, Java has a lot more in common with the Lisps and the C sharps and the F sharps and the JavaScripts and the TypeScripts and the Erlangs and the Luas and the Rubies and the Pythons and the Perls than it does with the C and the C++ and the Rusts and so on. It's not a systems programming language per se, as we normally think about it, right? It's an amazingly efficient language. And there are two reasons for this. One, when I say efficient, I mean both fast and it doesn't waste, right? It doesn't create a lot of waste. There are two reasons for this. One, of course, is the Java garbage collector. The Java garbage collector is, I think, just an amazing piece of software. It's a miracle of modern technology. That said, I would disagree with the nomenclature because, in my mind, Jesselyn is the original Java garbage collector. Okay? And yeah, that tweet went viral. And that makes me happy because there's a lot of people who both understand where that country is and care about software and garbage collectors. See, just when you think the world's on fire, some things are okay. There's 20,000 people out there that I could probably have a conversation with. That's good to know. So anyway, I think the Java garbage collector is truly amazing, really, really, truly amazing. But it's not the only thing that makes Java so darned efficient, so darned effective in production. The other thing is the just-in-time compiler, right? The Java just-in-time compiler looks at your code and it finds frequently accessed code paths and it turns those code paths into operating system and architecture-specific native code. The result is phenomenal, right? There's a reason that large organizations use Java in production. Large organizations like Google and Alibaba and so on. And a lot of these organizations have even gotten to the point where they understand this dynamic that exists with the JIT, and they actually warm up their application so as to trigger, to incite that native compilation, right? So they'll take a JVM application, exercise it, put it through its paces, send a lot of traffic to it to get certain code paths warmed up and turned into native code, and then they'll deploy those just to take advantage of this amazing JIT technology. And there's a reason, it's for that reason that sometimes an inefficient Java program can still sometimes be faster than a well-written C program, right? Crazy though that may sound. Not always, but sometimes. And that's because of the magic of both the garbage collector and the JIT. These things working in tandem make Java phenomenal. We just talked about these new things like checkpoint and restore. That checkpoint and restore is, like 2 milliseconds or something to get an application going from start to like it's serving traffic. It's nothing. It's so crazy fast. You blink, you literally blink and you'll miss it because it doesn't restart the app. So you don't see the logs, right? It takes the app to the point where it's ready to serve traffic, skipping all the state that led to that. It doesn't replay the state. It just goes to that state directly. So it's phenomenal. The Java ecosystem is growing. It's growing all the time. One of the most exciting things that has happened in recent memory is that Java has, the OpenJDK project has received a donation from Oracle. Oracle has donated GraalVM to OpenJDK, right? That was announced at Java 1 last year. And the reason they're doing that is because GraalVM, which is a separate project, it's a research project, has sort of existed on its own cadence and its own timeline, separate from OpenJDK. And this is kind of weird because it meant that even though both are coming from Oracle, a lot of you can get an Oracle distribution of Java from Oracle based on OpenJDK, and then 6 months later you get a GraalVM distribution of Java from Oracle based on OpenJDK, but they don't come out at the same time, right? And GraalVM would lag 6 months or a year or whatever behind the main distribution. And GraalVM is amazing. It does some amazing extra things. It's not just a drop-in replacement for OpenJDK. It has some extra utilities, one of which is a polyglot runtime called Truffle, which allows you to take, you can take Python code and Ruby code and R, for analytics and all this stuff, and then run it on the JVM, on the Truffle JVM. That's one thing. It also has a just-in-time compiler. That's what the original, genesis of the GraalVM project was to provide a hotspot replacement. And it also has something called the native image facility, right? The native image compiler. And what that does is it has the core conceit of that is, hey, if turning my code into operating system and architecture-specific code is such a good idea, why not do it for everything? Why not just proactively turn the whole application into native code up front before I even deploy it? Why bother putting it through its paces and then adaptively turning it into native code? And it's a good question. But the problem is that, like I said, Java is very dynamic. It has a lot more in common with these dynamic languages. Consider the case of eval, right? How many of you have ever used a language that has a version or a permutation of eval? The basic idea is that you can take a language like JavaScript or TypeScript or whatever, or Ruby or Python or whatever. You can eval a string, which in turn contains a statement that were it in a source code file would actually be a valid statement or expression in that language, and it'll evaluate it for you. You can't quite do this in Java, but you can, in a roundabout way, get the same thing. You can take a Java lang string that has as its contents the source code for a Java file, a Java source code page. You can then compile that at runtime, right? After your application is compiled and deployed and running, you can then, in your Java program, compile source code into class files. You can write that to the disk. You can load it into the class loader. You can reflectively create a new instance of it with class.forename. You can call methods on it using reflection. You can serialize it over the network socket or onto disk using serialization. You can create a proxy out of it if it's an interface using the Java proxy mechanism and invocation handlers. And you can do all of that with stuff that didn't exist at compile time, right? And that's all because of Java's runtime. It's an amazing piece of technology. It's what makes Java so dynamic. And that dynamic nature has made Java so flexible and so able to cater to all these different use cases for the last 27 plus odd years. It's an amazing piece of technology. And all that stuff, I like to call it fun, all that fun really offends GraalVM. GraalVM hates fun. It hates it when you have fun. Because it can't optimize that stuff. You see, GraalVM has a very simple idea. What if we could be 100% certain about what's going to be used at runtime? What if I could be 100% certain about which types are going to be used at runtime? If you could be that certain, then you could throw everything else away. All the stuff that isn't being used from the JDK and the JRE, great, throw it away. All the stuff from your class path and all the libraries on the class path, throw that away too. Just keep the very bare minimum required so that your program runs. The problem is that in order to determine which types it uses, it does an analysis at compile time. And this analysis, it's not deterministic. It can't deterministically see everything you're going to do. It doesn't know that at runtime you might concatenate a bunch of strings and then try and eval it, basically. It can't know that. It doesn't know that you're going to create new types from whole cloth at runtime. It just doesn't know. And so those things, when you do those things at runtime, they fail. So GraalVM has an escape hatch in the form of a bunch of config files, JSON config files that you can feed into the GraalVM compiler. These JSON config files, you use them to account for things like reflection, proxies, serialization, resource loading. Like if you want to load a property file or a fav icon or whatever, all that stuff lives in the jar. You have to account for that because there are no jars and there is no class path once you're a native image, right? So you have to account for all the stuff in config files. And let me tell you, friends, there's a lot of it. There is a lot of configuration. It's it kind of reminds me of the Bruce Tate book. 20 years ago, there's a book by Bruce Tate called Bitter EJB. And he used one of my all-time Double Dutch favorite metaphors. He says, EJB 2 and 1, not 3. 3 is much better, of course, but the first two versions they required so much work just to start. You had to understand everything to be able to take your first steps, right? And he said it was like making someone eat the whole elephant. And that metaphor never left me. I think about that all the time. Like, who eats elephants, and why would you agree to it? And how do I get myself into a situation where that's what's happening tonight? I want to avoid that. Anyway, with GraalVM native compilation, basically everybody has to eat the elephant before anybody can do anything, right? Every library that's on the class path needs to provide configuration to account for whatever dynamic use cases it has. Or somebody needs to provide that configuration. So for the last several years, since 2018, the Spring team has been looking at this. We've had a number of different research projects, a number of different efforts along the way. And eventually we released and I'll never forget, in March of 2020, famously, nothing else happened that month. We released Spring Native 1.0, or not 1.0, the first release of Spring Native. And that was a research project, and we worked with the GraalVM team. We've been working with them for years to develop this, to build this engine. This engine went through many different iterations. Thank you so much for bearing with us through all these years and all these evolutions. And eventually we got to a point where we took advantage of the fact that Spring has different life cycle phases, right? So there's a new engine now that starts up a version of your application context, a version of your bean factory at compile time. So you might know that Spring has a bean factory which contains bean definitions. These bean definitions are just they're metadata about your objects. They tell you what classes your objects have, what fields, what constructors, what properties, which events, whatever. All that stuff is contained in this information, but it's not your object. It's a meta object. It's an object that tells you about the nature of your object, okay? So we create a bean factory full of these bean definitions at compile time. We create the bean factory, and then we allow code to visit all these bean definitions, to filter through them, to process them, to analyze them, and to then generate whatever configuration is required so that that object can live and do the right thing at runtime. So if you're a library developer, you can see that, hey, I'm going to be, I support building web endpoints. I have a custom annotation or whatever. So whenever somebody uses that annotation, I know I'm going to need to reflect on that bean. Okay, great. So we create a bean definition. You can see all the annotations. You can see all the the interfaces that are there. You can programmatically write out configuration, and that'll get then fed into the GraalVM native image compiler. So we built this meta model engine, and it runs at compile time. It analyzes your code, and it gives all the interested parties, just like Spring Boot auto configuration, it gives them all a chance to participate and contribute, and then all that gets fed into the GraalVM native image compiler. So hopefully, for you, stuff should just work. But just being honest here, it's not going to always just work, right? Things are going to break because, to the extent that's possible, we've done as much as we can so far to move all of the Spring libraries proper up to the latest and greatest versions. But we can't know what libraries you're using. You might use a library from, the distant past, like 2019 or something. We can't know. We just can't know. So either you need to learn about the programming model and learn how to programmatically contribute those configuration files, or you have to craft your own JSON config files, or whatever. The point is, there's going to be issues. So Spring Tips, GraalVM, you might check out this video I did. It's called Spring Tips, The Road to Spring Boot 3 Ahead of Time Compilation in GraalVM. It's a 2-hour slog. It really is. There's a lot of stuff here. It's like a masterclass in AOT and GraalVM. It's not just like the getting started. The first 20 minutes are your getting started experience, right? But everything after that, if you want to become a library developer that knows how to contribute and work with AOT, everything's here, right? You can learn how we do code generation, how we generate the AOT. All the details are in this video, so I encourage you to watch it. Not now, definitely not now, but it's good.
2 hours?
Yeah, 2 hours and 8 minutes.
It's called tips?
Yeah, lots of, plural, more than one tip. Yeah. If you want more abbreviated stuff, check out my new channel. Yeah. Okay, so let's try this out, okay? All that forewarning and foreshadowing aside, let's try turning our application into a native image. So Gradle W native image, right? Let me just make sure. Grep native, I think it's just native compile. Yeah, very good. Native compile. Goody. So that'll take about a minute, right? This takes about a minute in my machine to turn it into a native image. And to be honest with you, friends, I get bored easily, And this kind of reminds me of the old XKCD compiling cartoon. Anybody remember this one? Right? Two programmers on their chairs, swashbuckling, and it's the #1 excuse for legitimately slacking off. My code's compiling. That joke didn't make sense to me when it first came out a decade ago, right? I never understood why that was. Who has so much time that they can get that distracted? Certainly not I, right? But, here we are. Time has a way of making fools of us all. So I get that now. I get distracted. And the problem is the compilation time is long enough that you lose your flow. You lose the focus that you had. But it's not long enough that you can do something interesting, like go to the bathroom or make a cup of tea or whatever, right? With the bad old WebSphere days, I had like an hour. I could go read a chapter of a book or something before that thing started. Now, no, I don't have that anymore, right? So it's a little bit of a problem, and frankly, I just find myself sitting there glass-eyed, waiting for the compile, waiting for that to happen. And so eventually I thought, well, gosh, I wish I could, because I hear elevator music in my head, right? And eventually I was like, well, I want elevator music. So I asked. I went to the GraalVM project, and I said, please play elevator music during the native image compilation process. And I said, look, I already hear elevator music in my head while I do these sometimes long-running compilations. I just like everybody else to hear it, too. Thank you in advance, because I'm polite like that. So I said, thank you in advance for your amazing work. And then somebody else suggested this, which I thought was a great choice. Okay, I thought that would have been good, but it's probably not going to work, right? And then somebody else said, well, maybe we could use a beep, like a bell code at the end of it, right? So that when you're done, you know to come back. And then this guy, this gentleman, his name is Fabio Niephaus. Forgive me if I'm butchering his name. He's a researcher on the GraalVM team at Oracle Labs. Smart, right? Really interesting guy. And he worked on guitars. So he responded with this. He says, can you all see that? I'm worried. Yeah, there you go. Thank you for your feature request, Josh. The problem with playing music during the compilation process is that it's just fixing the symptoms, and we've been and are still working on the cause, making GraalVM native images more efficient in terms of time, memory, and CPU consumption. Anyway, I have prototyped a -- Josh Long mode. But for some reason, I have the feeling my PR will be rejected, probably because of the copyrighted music. And so anyway, here's what that would have looked like. My Josh Long mode prototype for GraalVM native images. And it would say, music brought to you by Josh Long. And that would have had, yeah, spring all the way. So anyway, he was, good sport about it. And he says, on a more serious note, yes, we could add a dash H. Where'd it go? Yeah, he says, yes, we can add an H ring bell when done option that prints the bell code after the compilation process. So, change is in the air, friends. Things are going to be great. Anyway, to do, and yeah, it was good. Okay. Anyway, that's our application. It's compiled. Like I said, it took me about 1 minute and 5 seconds to build that. That's a pretty stock standard, typical app. I've got database. I've got web. I've got embedded databases. I'm not just connecting to somebody else's database. I'm actually starting the whole SQL 99 compliant SQL database in process, and all that's there. It took me about 1 minute and 5 seconds. So I go to the build directory, I go to the native directory, I go to the native compile directory. It really just rolls off the tongue, and start, okay? So there's the application. Let's try again. There's the application again. You can see it's fast, right? Faster than a light bulb, 0.082, 82 thousandths of a second to start up the application, which again, I don't care. Like I really don't. That's not, unless you're doing serverless, in which case, yes, this is the solution that you need, right? This is how you get Spring Cloud function plus this equals a viable stack for building serverless functions. What I do care about, however, and I think all of you will care about, especially in the era of the recession, cloud austerity being a must, I care about reducing my spend. I care about reducing my footprint. And to that end, I think this is a pretty amazing technology. So we can look at the PID, first of all. Here's the process identifier for our application, 96556, okay? Take that, and I can do PS minus O, pass that in, whoops, PS minus O, PS RSS, okay, what did I do wrong here? Nope, I have a script that I was gonna show you the atom, but who cares? Let's just go to the script. RSS by PID. Come on. Goody. So there's the script, right? minus O RSS. That's the command, right? It'll basically, you give that, so PS minus O RSS, that, and you can kind of guess what that number is, but I have the script that scales it out for me, right? So we'll take that. And there it is, 100 megabytes, okay? So it's 100 megabytes of RAM. Now, I don't know how much RAM you're taking on your application, but I'll bet it's a far sight more than that, right? That's the important part here. And even if you start throwing traffic at that, maybe if it doubles, right, in the worst case, right, you're still doing a far sight better than you were doing otherwise. I don't know how much you're using, but let me guess, about 1 gigabyte. Is that about right? Who's using 1 gig of RAM in production? More? More, yeah, that's pretty typical. incidentally, and this is anecdotal, in 2004, I remember walking through a data center. Yeah, in 2004, I remember walking through a data center in Phoenix, and in Phoenix, that's where they keep the sun, right? So I was looking for air conditioning. It just happened to be a data center. It worked out, right? So I was walking through the data center. I logged into the machines in our rack, and I just remember logging in. I'm like, I wonder how much RAM these things are taking. And back in 2004, again, a minute ago, right? A hot minute ago, I remember looking at the machines, and they all kind of had like 2 gigs of RAM. This is back when we had application servers, right? So co-located apps, co-bundled onto the same deployable, right? A fragile house of cards if ever there was one. And I remember thinking, gosh, 2 gigs of RAM, that's insane. It's a lot of RAM, right, for a single deployable, although that meant several different apps. And we wanted more. And actually, in the years that would follow, there would be all these different attempts to make it so that the JVM could address more RAM. The big thing that made it possible was moving to 64 bits, right? JVMs back then were 32-bit. So being able to move everything to 64-bit, that gave us a lot more addressable RAM. But still, the JVM couldn't really keep up with it, right? It wasn't fast enough to keep up with that much waste, that much garbage. So it just became kind of like a convention. You didn't do more than 2 gigs of RAM, right? 2 gigs of RAM is about as much as you could get away with without issues. And eventually we had this whole era of like all these different vendors building distributed data grids. And their big claim to fame is, hey, we made Java address 1 gigabyte of RAM, right? And they did this by having just a giant malloc statement. And they managed it, they call it off heap, right? That was a bit of a, it's amazing that it works, but it's kind of sad, like the JVM shouldn't be forcing those decisions. So I just remember thinking, gosh, 2 gigs of RAM. Now here we are, 100 megs. We've come full circle. The applications today take less RAM than they did 20 years ago, almost 20 years ago, 19 years ago. So I like GraalVM. It's fast, it's awesome, it works well. There's a lot more to be said, surely. Go ahead and watch that video, but let's move on. So I want to build now a client, okay? Good, here's my client. Refresh. I'm going to build a client, and I'm going to bring in the GraalVM support, sure. I'm going to bring in Spring Cloud Gateway. I'll bring in GraphQL, okay? I'll bring in the reactive web support, and I'm going to hit generate, okay? And again, I'm naming it client because I'm great with names, so it's obvious. Okay, UAO client.zip. Open this up. Oh, running out of coffee. Time to wrap this thing down. There's a Spring Cloud plugin. I didn't know that. Did you know that?
Really?
Is it? It must be good. I don't know. Okay, so good. So here we are. We have our client. I want to talk to the service that we just built. I want to make the data available to the consumers of my service, right? And so this is a logical client. It might be an edge service. It might be something that lives at the logical edge of your architecture. It's the first port of call for requests intended for your downstream services. There's a lot of ways I can expose that data and centralize it. One way might be to use a API gateway, right? And one way you can do that with Spring Cloud, which has also been updated to work on Spring Boot 3 and to use AOT support. One way you can do that is to use Spring Cloud Gateway, right? And the idea with Spring Cloud Gateway is that you have routes, and these routes are predicates that match requests coming in on port 9999, let's say. And when the requests are matched, we can then forward them on to something else. So let's just act like a proxy in this case, okay? Port 8080. The trouble, of course, is that if I take a request coming into /proxy, I want to transform the request and then forward it unadulterated onto localhost 8080. But I want to be able to act on that, and in this case, I need to act on it because the path on which the request comes in is /proxy, but the outbound path we want to be customers, right? So I'm going to basically do a rewrite. So I'm going to use a filter here to say set the path, okay? So I'm going to take the request that comes in, I'm going to change the path, I'm going to set the path from proxy to customers, and I'll send it on to localhost 8080. These filters are where the power of Spring Cloud Gateway is, right? You can add, for example, a response header, HTTP headers dot blah, blah, blah. I can do cores. There's all sorts of other filters here. You can do retries and rate limiting and, let me see, rate limiting. all sorts of stuff. Okay, but we're not going to linger too much on that. Okay, so that works. Let's just go ahead and start this up and see what that gives us. Okay, oh wait, it's running it as a, okay, good. Curl, HTTP, localhost 9999/proxy. Okay, there's the data from our downstream service. It's worked. What about -v? And you can see -v, we can see that new header that we added there, right? Adding core support without changing the downstream service. So you can interpose things like security and routing and compression and all this stuff in the API gateway layer. Great, easy. What if I wanted to do something more than that? What if I wanted to actually talk to the service and maybe act on the payload? Well, here I could write a Java client to talk to my API. And it would be very natural to distribute that across the organization so that other organizations, other teams can just use that blessed client to talk to our services. Now, in the past, you could write a client manually by injecting the REST template of the web client, but there's also some options there. You can create a declarative client by using Spring Cloud Open Feign, not Fay. You can use Spring Cloud Square Retrofit, right? If you want to do reactive HTTP, right? So this is just blocking HTTP. And if you're doing RSocket, well, your humble Spring developer advocate, Josh, I worked on something called RetroSocket, right? And this is an experimental project that will never go anywhere. It's done. And there's a reason. It's because all these things have all been subsumed or succeeded by something that's been baked into the core of the Spring framework, okay? And that is a declarative interface-based mechanism for creating clients for different protocols. We have support for RSocket today and HTTP already, but I can imagine a world where we have something with GraphQL maybe and other protocols. Do you know any other protocols that I'm missing? Okay, good. So here's an idea. Here's the implementation. Customer, client. We're going to create a DTO of our data. Where is this? Here we go. Copy and paste that. Don't do that at home, kids. Paste that. Okay, so a publisher, a reactive stream of customers and a reactive stream of customers by name, like so. Good, so that's my interface. I don't want to actually implement it. I want Spring to do that work for me, but I need to tell Spring what to do. So I'm going to use these new annotations, new in Spring Boot 3, called get exchange. It's called request exchange. It's like the client-side analog to request mapping on the server side. So here's the annotation for the client call to all the customers, and here it is for the name. Some of the server-side annotations still work, like @path variable. It makes sense on the client, so you can still use those to do URI parameters, right? URI template parameters. But basically, with that done, I can now create a bean, not nested, bean, customer client. Okay, now in order for this to work, I need WCA web client adapter for client. I need a pointer to my reactive non-blocking web client. I'll use that. So I'll say builder.base URL HTTP localhost 8080.build, okay? And I'll say HTTP service proxy factory dot builder, passing in WCA, dot build dot create client, and here I can just give it the interface. So you can imagine a lot of this stuff could be extracted out into separate little beans, but whatever, okay? I'm just gonna keep it all here for now. And that's it. So now we can actually inject that client and use it somewhere. Let's try that. Application listener, application ready event, right? Here we are, return, new, application ready, blah, blah, blah. And we can use the bean here, customer client. Voila. So cc.all.subscribe, print line, voila. Replace it with a lambda and restart. Okay. What's it doing? Is it running the Gradle build for each one? No, don't do that. Just run this locally, please. Much better. Goody. So there, you can see it started up the client application. It started up, and I called the endpoint, the HTTP endpoint. I got the JSON back, and it turned it all into Java objects, and it let me print it out just like it did when I ran it from the database on the service. Okay? So this declarative client mechanism is very convenient, and there's all sorts of stuff you can do to like add security and convey headers and all that stuff, but you get the idea, right? Okay, well, this is the second thing we can do to make it easy for our clients to consume our data in a consistent and ideally secure way. The third thing we can do is to use GraphQL. Now, GraphQL is not a new thing. It was created at Facebook, Meta today, but Facebook then. In 2012, it was created in response to a number of people that wanted to build services, and these services didn't necessarily live together, and their clients wanted that data to live together, right? Think about the tension that we have today, even now. I want to build microservices. I want standalone, succinct, independently deployed microservices that do their own thing and that have their own domain model on different hosts and ports that I can then deploy independent of each other. My iPhone developers and iOS developers and HTML, JavaScript developers, they all want all their data in one fell swoop as fast as possible in as few round trips to the server or servers as possible. So there's a tension. They want all their data at once, whereas for ease of separation of concerns and consistency, we want all of our data in as many places as possible to keep it clean and isolated and modular. So GraphQL is great for bridging that divide, okay? And the reason is it provides, first of all, a very pragmatic approach to building services and exposing data. It also gives you schema, right? So it's very clear and easy to understand. And also it makes it very easy to pull together data from disparate sources. So let's go ahead and use this to build a GraphQL endpoint, okay? So we're going to go to source main resources. We're going to create a folder here called GraphQL. In source main resources, we're going to create a new file here called schema.graphqls, right? Like GraphQLs. And then we're going to define our query, okay? Now in GraphQL, it's very pragmatic. They only have 3 verbs, right? Compare that to HTTP's 6 verbs, and you can see it's already 50% less verbosity. There's subscriptions, mutations, and queries, okay? A query is a thing that reads data. A mutation is a thing that changes data. And a subscription is a thing that reads data and keeps on reading it, right? Like imagine a stock ticker or sensor data or a chat, right? You don't want to create a new socket every second to ask it for new information. You just want to keep one socket open and get updates as they arrive. That's a subscription. Queries are just, I want to, give me this record by its ID. That's a query. And a mutation is everything else. Everything, right? If you want to change data in any way, be it creating it, updating it, deleting it, that's all in the province of a mutation. This makes it super easy to understand, super easy to rationalize and to build for, right? So here we have to define a type. By convention, it's just called query. This type will in turn expose a field called customers, and we'll have another field here that returns all the customers with a parameter of name, right, a string parameter. Okay, so that means that we have a type called customer. Let's define that here as well. Okay, there's that. And now I want to actually implement this in my code, my Java code. So I'll build a GraphQL controller using the Spring for GraphQL project. So class GraphQL controller, and I can, for consistency, GraphQL customer controller. Okay, and this is just a regular @controller. And I'm going to say schema mapping, type name is equal to query, and the field name is equal to customers. And I'm going to use the service that we just built, the client rather, the declarative client. I'll use that to do the work of connect, come on, private please, thank you. Customer client, CC, in that, I forgot to put Lombok in here. So okay, customers, good. Like that, return this.cc.customers are all, and then another endpoint here, schema mapping, type name equals query, and the field will be customers by name. Come on, customers by name, publisher of customer, customers by name, and the parameter will be called argument string name. Okay, return this.cc.by name. Voila. Okay, there's our basic definition. Now, remember what I just said. There's only 3 verbs. So here we're using the high-level schema map, or the very low-level schema mapping. But really, we're doing a query, right? So there is actually, in the same way that there's a request mapping and get mapping, there's also a query mapping. In fact, Spring GraphQL will imply the field name by looking at the name of the method, and it'll default the type of thing to query in this case. So that works as well. That is identical. This is semantically identical to the thing that's commented out above. So I'm just showing you the long way so you can know what's possible. But for a lot of times, you might just do that, okay? Let's try this out. So I'm going to go to my property file. I'll say graphical enabled equals true, and I'll restart this. Go to the browser, localhost 9999 graphical, okay? And, refresh, close this out, close that out. Good. Query, I get control space ability. I say I want all the IDs, great. Pretty print, great. I want the name, great, get that back. So I get as much or as little data as I want. This is very convenient, but I can actually add new things to the graph, right? That's why it's called GraphQL, without really disturbing or making the client aware of where that thing is coming from. So suppose I had another microservice. I don't, we don't have time, but suppose I did. What if each customer had a pointer or a record of a profile, and that comes from the profile service? And you can imagine how that would be implemented behind the scenes. For each customer, you'd make a call over the network to the profile service by ID. You'd say, give me the profile for this customer by its customer ID, okay? So now I'm gonna create a new type here to represent that. I'll say record, profile, string, what did I say? Integer ID. So now my Java code, this customer type has no record of profile. But from the perspective of the consumer of my GraphQL API, it makes sense to think about these things as being, the customer is an aggregate that contains a profile. Okay, so I'm going to create a new endpoint here, schema mapping, type name equals customer, and the field name equals profile. Okay, and again, you don't need to specify the field if the method name itself matches what you're doing there. So I'll say profile. Now, how am I going to look up the profile for a given customer if I don't have a pointer to the customer? Simple. Inject the customer, right? So now, return mono.just new profile. Let's just say you can just imagine me making a network call here, but it's pretty straightforward, okay? Restart that. Almost done. Okay, so profile, whoops, refresh. If I go here, I can see now there's a profile type. By the way, look at that. If I try and do this, it gives me an error, right? It's saying you have to do a sub-selection. So great, I'll ask for the ID. And there we are, right? So I'm asking and I'm saying, give me all the profiles for these customers. And behind the scenes, it's working. The client doesn't know that these things are not actually in the same microservice. It doesn't know that they're necessarily even written in the same language. It doesn't care. It just gets as much or as little data as it needs. I can remove this and I get back just the subset of the data that I care about. This is still kind of expensive though. I'm making an N+1 network call. I'm getting all the customers, and then for each one, you can imagine, I'm making a network call to each profile service for each of the customers. Not great. So in this GraphQL Java project on which this is based, this implementation, and by the way, we worked with the GraphQL Java team for years to build Spring for GraphQL. In that implementation, there is a thing called data loader, okay? And the idea there is that you can optimize certain calls. So let's suppose you had an endpoint that, given a bunch of customer IDs, you could return all the profiles all at once. Well, how would you write that code, okay? I'm not gonna actually implement that backend API, but imagine the contract. It looks like this. New hash map customer to profile, okay? And then for var c customers map.put c new profile c.id, okay? And then just return the map. So this batch mapping endpoint is doing the same thing as this, but now GraphQL, Spring for GraphQL will be smart enough to just send you all the customers. So now instead of making N+1, in this case, a total of 11 calls, you're just making 2 calls, okay? So we can go here, rerun the same query, add profile back, add the ID, hit refresh, and I get the same results in far less time. So I'm benefiting from reactive programming because the types are non-blocking, and so as a result, it's doing things concurrently wherever possible, right? I'm also benefiting from the clean, easy orchestration that GraphQL provides by calling different microservices, and I can take advantage of optimizations like batching and so on. It just makes it very easy to expose this data. And yes, my friends, this application too can turn into a native image. So cd client Gradle native compile. We'll let that run, and it'll do its thing in the background. But in the meantime, my friends, I hope you got something out of this. I'm just about out of time. I just want to know who got something out of this. Who learned something new tonight? Okay, there's one person for who I am deeply sorry. But the rest of you, thank you. Really appreciate it. I'm glad you came. I'm glad we all came out, got to be here. Happy New Year. I'll answer some questions while we wait for this thing to do its work. Any questions? Yes?
Okay, in your sample data, like there is only 10 customers, but what if it's like millions of records? For
Yeah.
this method, who is going to be responsible for paging? You are not going to try to get millions of results.
No, you can pass in parameters. Like I said, I passed in names. So you can pass in like page 1 or whatever. You can do your own paging, right? And Spring Data has methods for that as well that you can use. I don't recommend doing a find all. That's not great.
We got one question here.
Yeah. By the way, Pratik, you did a great presentation on GraphQL a few years ago. Actually, I remember watching you.
Bringing GraphQL.
Yeah, that was a great one. We should do another one together.
Yes, we should.
Okay. By the way, here's that client. Oh, it's build native compile client. Let's make sure it's not running on the JVM. Is this the client? Yeah, that's the client. Ta-da! Okay, there you go. There's the client as a native image, doing exactly the same thing as the one that we just saw. Cool.
What was the GraphQL UI that you were using in your browser?
It's called graphical, Graphiql. Get it? Graphical. Oh. And actually, so this is the problem. It's so hard these days to separate the art from the artist, but there is api.spacex.land, right? I like SpaceX, just, So like they have this, they're using basically graphical as well. This is graphical, you can tell because it says graphical, right? And it's kind of if you want to like play with GraphQL before starting with Spring GraphQL, which you will definitely do, right? For sure, there's no better way to do it. Then check out this. It's a really great example of how you can build a lot of different services and make them easy to consume.
All right, here's one more.
And to follow up, for the distributed tracing stuff that you were doing earlier where we were returning an observable.
Yeah. Observable. No, observation. Yeah.
Observation. Is there an annotation that you can just...
Yes. @observed. Sorry, I always forget about that. Yes, @observed does the same thing. Yeah, it'll enclose the method in the same scope. Yet, great question. Perfect question. You should be up here.
We have other questions? All right. Oh.
Complaints? Tomatoes?
Question on the snake YAML vulnerability that was actually fixed in 3.0. In 2.7.7 that just came out, it actually represents about 7 of the 10 initial vulnerabilities the snake YAML does. In 2.7.8, in the name of Fortify scans, is snake YAML going to be fixed, or do we have to move to 3.0?
There's a vulnerability? I wouldn't know. I just work here.
All right. Thanks.
In that case, what I would do is,
Do you know?
no, I was going to say check the boot releases, and then you also could check the boot issues and look up snake YAML. I don't know either, but you can go to Spring Boot on GitHub and do a search for snake YAML on the issues and see if it's still open, or switch over to the closed.
Yeah, because there was a rumor that it was going to be fixed at 2.7.7, and then that just came out and it's not fixed. It's actually 7 of the 10 vulnerabilities. Just curious if it's going to be fixed at 2.7.
I have to check the site.
Sorry. We get a lot of reports of CVEs. Not on Spring usually. It's a big project. We pull in a lot of good stuff from,
In this case,
and things happen.
It's not Spring itself, it's the BOM that's using, and it's also
Bill of materials, BOM.
the snake YAML resolved the issue. And it could be that
Oh, no, they resolved it. It's resolved.
Okay, so that's good.
And it's resolved in Spring 3.0.
Okay.
They use 3.3. But this latest Spring 2.7.7, people thought it was going to be fixed. And actually, 2.7.7 started with 10 vulnerabilities, and 7 of the 10 are snaking out.
Okay.
Yeah.
Yeesh.
Yeah. All right. Good. Thank you.
Good engineers working on good things. Sometimes bad things happen sometimes.
All right. Other questions? All right. Well, folks, thank you for coming, and
Thank you.
Thank you, Josh, for giving the presentation.